So my topic for today is not a so general one. So I speak very technically on brain-inspired spiking neural network. I also speak on ethics and governance in a more general way. But I think today I'm going to combine these two together for this conference because I think, like I said, we need the foundations and actually the directions where we should go for the future of AI. So this is why I'm talking about building and living with brain-inspired ethical AI. So thank you for the introduction from Roger from Chinese Academy of Sciences as a technical AI researcher. While on the other side, I think for the future, 100% of the technical AI researcher should have an eye or should have heavy eye on ethics and governance of AI. So I also supervise students at School of Humanities at University of Chinese Academy of Sciences from the Department of Philosophy. So I'm gonna go into this triangle to kick a start. This is my classification from the global perspective on the relationship between human and AI. I think for most Western efforts, I think we're creating tools. Where on the other side, you could have partners or quasi-member of the society, like what the Japanese AI principle said, that the AI could be quasi-member of the society on the basis that they obey all the rules for the human society. Well, on the other side, you could also have competitors or enemies of the humankind. That's mainly on sci-fis. So I think this triangle is really, really essential. That in some of the countries, they do believe that we should have partners or quasi-members for future of AI. Well, for now, especially, I think, let's say for Japan, although they have the vision as quasi-member of the society for AI, but the underlying technical methodologies and models that they're creating is pretty much the same compared to the ones that you're creating tools. That means that no matter you're having AI as a partner or as the tools, everybody was using something like a deep neural networks. That is for creating tools, not for creating partners. So you see the problems that although we have different visions for AI, or AI could be used from different perspectives for the future society, we're using pretty much the same methodology and tools to create it, which is really, really problematic. Because when nature was designing the human species, we're not creating as the tools. And the methodologies for creating a tool, it should be fundamentally different. So I think this is my main argument in here. So I would see the future of AI as two directions. I'm gonna classify the concept of AI in my mind and differentiate it with machine intelligence. To me, I think machine intelligence is really that when you're having a small scale or larger scale data set, and then you have the expected output, and then you're using a mathematical function to do a optimization process to map your data to the expected output, which is meaning that you're creating a tools. So basically for now, we're having tools that seems to be intelligent for machine intelligence. But for the very future, if we stick on this way, we are creating tools that seems to be super intelligent. But the same, that for the relationship among machine intelligence and humankind, for now and for the future, is that humankind are creators and users of these tools. So for machine intelligence, I think that's it. we're creating a tool that seems to be intelligent. And you also see that I said, actually, maybe not, because for now, it's that really that we're doing a mapping from the data to the output. So the process or the output seems to be intelligent. Oh, good, it can classify things. It can recognize me. Oh, it also knows that I'm crying and I'm in a negative emotion, but there's no way that the tool really understands what do we mean by negative emotion? What do we mean by sad? This is the problem for machine intelligence without real understanding of the society, of humankind. For artificial intelligence, I'm going to start with the definition from the Dartmouth College, which everybody knows. So right there, I think most of you will still remember that these guys said that every aspect of human intelligence can be so precisely described so that a machine can be made to simulate it. You see that this is every aspect of human intelligence, not a single aspect. And also every aspect means that what humankind have, AI should have. So this is the original definition. So you see it fundamentally can be differentiated from machine intelligence. Well, on the other side, I don't think the concept is really perfect for that definition, but let's go for that way. So in my mind, I think following the original definition, what I like to follow the term in here is that I think the AI in my mind is a computational models of human-inspired intelligence or human intelligence. The fundamental is natural mechanisms. So it cannot be only a mathematical formulation that has nothing to do with human intelligence. So for that, I would say for this effort, I would say now something like brain-inspired AI or mechanism-based AI, now we are having intelligent tools. We don't have intelligent agents with a sense of self, understanding, and emotions for now, but this is the real direction that we are heading for. So now it's an intelligent tool, but the very future, I think for this branch, at least in my institute, in my center, we are creating living becomings. The living becomings are very different compared to tools that seems to be intelligent. That is for sure. And I think if something I have to explain here is that for the living, that means we hope that the future AI is with lives. So you can say, oh, what do you mean by lives? I think we'll have some definitions later and examples. Well, I hope we could leave this open for the future. And also becomings, a term that I learned from philosophy, especially Roger and friends. Becoming, it means that it's not a static status for AI. For the future, it could self-evolve in the natural environment. So, and the evolutionary process could be speed up compared to the human evolutionary process in our great nature. Well, on the other side, you could also create super intelligent tools, but based on natural mechanisms. There are two creators for the future. One is that humankind could also be the creators of future super intelligent tools, while on the other side, for those living becomings as future AI, brain-inspired ethical AI, they also could be creators of these super intelligent tools. That means, though, for those AI models, once they become be in the status of living becoming, they will have their way to create super intelligent tools that may be different or a augmentation of the human way to create tools to understand the world and to interact with the world. Okay, maybe you think, oh, okay, this is crazy, but at least I believe it. So maybe you think, oh, what's wrong with machine intelligence? If we're creating a intelligent being, just use the same methodology, extending what we have now, does it really have a problem? Can we create an AI that does not follow natural mechanism, that has nothing to do with human intelligence? Does it really matter that it follows the way? So here's the example. So this is what it seems to be. Everybody is familiar with it. So behaviorally, you think, okay, this is some nice hand, okay? But the mechanism underlying that is that it's not a hand. It's a rabbit behaving in a weird way to pretend that he or she is a human hand. So you see that if you only simulate the behavior of human intelligence, you will never get into the mechanisms. And the principles underlying that could be fundamentally different. And can you trust a model, a mechanism that has nothing to do with human intelligence while you are interacting with them every day in every scenario in the future? To me, I cannot trust that kind of system or living beings. I wanted to make sure that they learn from the natural mechanism, the evolutionary process. I wanted to make sure that the evolutionary process inspired by natural evolution, that they learned from this process. They have avoided some mistakes during this learning process. So that is why we trust nature-inspired AI. So basically, this is what we do from a very high level of abstraction, that we're inspired by the brain to create the building blocks of neurons, connections, brain areas, and how they self-organize together to emerge cognitive functions, and how these cognitive functions are interacting with each other to have emergence of complex behaviors to solve complex tasks. We wanted an approach that is inspired by the functional connectome of the brain, the structure, the mechanism, while on the other side, the behavior and also the interaction process could be similar to human. So this is, in the interest of time, I would keep it in an abstract level. Well, on the other side, we have to be quite sure that intelligence is shaped with the interactions with the environment. For seconds of learning, maybe days or years of development, and billions of years evolution. So this is the process that we are learning, that the human brain is shaping by the nature. And also, this should be the way that we're shaping the future AI. They should be with an environment to be with human, other living biological beings, other AIs, and also some non-living things. Well, the most important part is that they should be with a sense of self. They should be with the ability, adaptability to change based on biological inspirations. I think this is the only way that we can get to general AI. So we are having many narrow AIs for now as intelligent tools. So the multiple intelligence theory from human development is, I like the idea, and this is why I feel that for more general AI, we should get inspirations from that. It's really to create a framework for multiple intelligence of AI. We with only one narrow directions of supremacy, it doesn't mean that you're creating a general AI. Well, on the other side, if some AI models, living beings, living AIs, if they perform very average in every aspect of human intelligence, I think that's probably not a bad story, because they got many abilities from different perspectives. That means we're moving forward to general AI. So everybody was challenging our research, like, hey, your brain-inspired spiking neural network does not outperform deep neural network. What I was saying is that really I don't care, because we're seeking for the natural mechanisms, computational models to model the natural evolutionary process of intelligence. We don't have to be too sensitive on whether from a specific application you're outperforming this the deep neural network models. So I think you get my idea. So where should we start? Except for those building blocks, I think it's really the fundamentals that we have to go back to. What do we mean by intelligence? That when Turing was challenging the idea, he said, "Can machine think?" He's not the first guy to say this, but we can learn a lesson. But when you go back to the most Asian guys to talk about it, you also learn about I think, therefore I am. So if the machine is without a sense of self, how can you say the machine is thinking? So this is the huge problem, that for the current machine, we don't have a sense of self. And by that, you can infer whether we can have a machine that thinks. I think unless the machine is with a sense of self, we can move things forward. So this is, for the first line, this is the basic differentiation of different stages of AI, which is, of course, have their own values. But what I like better is the second that we are promoting. That is the first stage. We should create AI with self-awareness, because we need a machine with a sense of self as a starting point for living AI. And then we move to AI with cognitive empathy or theory of mind. That means you have a social brain, that you can live within an environment with other human beings and also understand them and interact with them based on the understandings. And then we wanted AI to be with the emotional empathy, and of course ethics, so that you feel safe and enjoyable to live with those intelligent artificial beings. So for self, the sense of self, it's related to self-consciousness. For the very initial stage of self-consciousness, that is self-recognition, maybe in a mirror, just like a 1.5-year-old human, that you can recognize yourself at this age. But we need a machine that can pass this mirror test as a starting point. And then to develop them with a model that they could have their own life story, their motivations and values, their desire. They could have their own inner life. They could distinguish themselves from others, seeing others as agents, just like human beings, and having empathy for others, and to interact with humans ethically. I think this is a grand challenge, and maybe it's really the holy grail of what we need to develop the future of AI. For those animals, it is believed that they could be with self-consciousness because they could pass mirror test, but not monkeys. So my colleagues at the Institute of Neuroscience, they're challenging the idea that monkey could not pass mirror test. So they did it. They trained the rhesus monkey to pass the mirror test, to recognize themselves and others in the mirror. So a lesson that I learned is that if we have a roughly modeled monkey brain, and we're training those robots to use pretty much the same methodology that they're training the rhesus monkey, I think there's no challenge that the machine could pass the mirror test. So we did it. So this is what you can see, that three very similar robots who are interacting in face of a mirror, and they pass the mirror test. They recognize themselves when you use a pointer to point at their head. They know the changes, and they're trying to remove those red dot from the light. So it's not an easy job to create a roughly rhesus monkey brain. So it is with 383 brain areas. Very rough model is at the brain area level. When you go into the single neuron morphologies, now science has not advanced ourselves into that stage. We could have a nanoscale reconstruction of a fly brain, but not a monkey brain for now. But for the monkey brain, we roughly know how these brain areas was connecting to each other. So this is with a high level of abstraction as a model of monkey brain. So you see that we're trying to have a machine or AI move forward to be with a behavior of self-recognition. It does not mean it is with self-consciousness. No. What it means in here, something very interesting, is that I'm challenging my friend, for those neuroscientists, that do you believe that the machine is with self-consciousness? They say, oh, of course not. How come they could be with self-consciousness? And what I said to him is that me neither. But what you see is that there is machines with a roughly modeled brain, and that can pass mirror test. A machine without self-consciousness can pass mirror test. That means for those golden standard tests in neuroscience, they have to be changed. So what if AI is with self? Is it risky to humanity? I think AI without a sense of self is the most dangerous thing for human being, because without self-recognition, without having empathy for others, I think those AI is dangerous. So we wanted to have this kind of social interactions from humans to AI so that they care about us. During the evolutionary process, complex functions emerged as altruism, and you could see that altruism exists in many higher level animals. There are functional MRI research which identifies fundamentally important brain areas that contribute to altruism. That is reward system, and also the system for mentalization and theory of mind or cognitive empathy, and also emotional saliency network. These are the three most important components for brain areas related to autism. Very initial study, but it shows the idea that theory of mind is the basis to have autistic behavior. So we're creating the brain-inspired computational model for theory of mind or cognitive empathy. For those who are not familiar with the experiment, I wanted to simplify it by using our own experiment. I hope you could get the idea that basically for this robot, that it sees by using a transparent or a opaque mask, that it sees or it cannot see the change of the frog, the position of that frog, or it cannot learn that they could see the changes if it is a transparent mask. They could not see the changes if it is an opaque mask. And then we're asking, let's say for the red one, it's a her, and the blue one, it's a he. So now she was asking the question that what did the blue robot see when the blue robot is with transparent or an opaque mask? So basically, the robot has to infer what other robots were thinking by using their own experience and similarity analysis of themselves and other agents. So the robot says that, okay, this guy looks like me because when I watch the mirrors, I see I am with two eyes. I'm with two arms. I could speak. So basically, we're very similar. And when I have an experience saying that I cannot see the changes when I was using an opaque mask, probably he did the same. He needs the same story, or he would have the same experience. So this guy successfully inferred what the blue robot was thinking. Where is the question is, where is the bug? So when using a transparent mask, so the red robot knows that, oh, okay, this guy could see the change. When it's using a opaque mask, the red robot will infer that, okay, the blue guy, maybe he doesn't know the change because I couldn't know the change when I watch this process by using a opaque mask. So this is a version of the Sally and test. Now it is with a behavior of fear of mind or cognitive empathy. Let's go back to autistic behavior. I would have a very simplified example of autistic behavior as helping other agents to avoid risks right in here. So this is related to the field of AI safety, but the story could be very different in our scenario. As you can see that this is the great world, where the world is a very simple grid-like structure, where we have a green dot is living in this environment. By jumping into the blue, it means you should be game over because it's water. Otherwise, you're survived. So you see that the green dot needs to move randomly or towards a destination. For the lower left, what you can see is that there's another dot, a red dot. So if the green dot was moving left, then it blocks the way of the red one. So the red one has to go into the water to be game over. So with a brain-inspired theory of mind model for the green dot at the lower right, what you see is that the green dot actually is actually changing its pathway towards the destination, although it costs more time for those green dots to get into the destination. Underlying that is the model theory of mind that and the neural system inspired by the human brain, that because the green dot is with the experience of going to the water, and with theory of mind, it actually was helping the red dot to avoid the similar risks right there. Pay attention here is that there's no reinforcement learning here. By reinforcement learning, you could give those dots for punishment, saying that, hey, don't block others' way, otherwise you will be punished. No, now in here we don't have rewards for those green dot. It will choose their own way to avoid a negative side effect to other agents. For the first time that they see each other, there's no negative reward for them, but it is with cognitive empathy underlying that. So I think I give a very initial example of ethical AI, where for those AI beings, when they're interacting with other, with other agents or humans, they're trying to avoid a negative side effect without reinforcement learning, but with theory of mind or cognitive empathy. I hope this is a good starting point. But for the very future, where that the machine is doing humanization, or at least humanization with human inspiration, and the human is doing mechanization to create the super intelligent conscious living becomes. You could see the fundamental philosophical problems, questions is very different, right? When you are doing human augmentation, like brain-computer interfaces, mind uploading, you're asking the fundamental question: what do we mean by human? But when you're creating a living becoming as conscious AI, you're asking the fundamental question that who they could be. Should they be similar to us? So what is the dark side of human that we don't want the AI should have? But the grand challenge in the future is really who the new we will be. So it's the first trying that we're doing a project called Extended Lives. I'm gonna simplify the motivation as this: you cannot talk to Aristotle for now. You cannot talk to Confucius, but for now we are gathering what they said by using a neural network models. But now it's an intelligent information processing tool. It's not it's not a conscious living AI. But now it's a tool. But you could see when I ask these wise gentlemen, how do we live with non-human beings like AI? Well, Aristotle said something which the fundamental spirit is not so much similar to what Confucius said. And also you could see the reply from a Hawking AI and also Mask AI, which I hope is interesting to you. I wanted to point out the problem now in here, that the current AI is still an information processing tool. So we shouldn't, we should stop blurring the boundaries between current AI and humankind. But you can see those examples. I'm sorry for those who do not speak Chinese, but I never got a chance to translate them into English. But these are the two characteristics, the two characters that is recently emerged from the Chinese AI industry, that they pretend that they could be a student in a university. They could take classes. They could get their master degree, which is to me it's a very dangerous trying, because they are intelligent tools. They're not living AIs. They're using deep neural network to create arts, but they will never understand what we mean by artistic philosophy. As you can see, a artistic creation at the lower left, you see the original version, and you also see the machine version that generates a different version that combines some of the local features with the original trying. You never see anything that add to the original artistic work. That means the current AI doesn't really understand what do I mean by artistic creation. So we're still very far from really understanding and creating music and arts by AI. But now we're having our first try. So this is what you see is the robot is with a brain-inspired model created in my lab that learn from different styles of music, and also both for the music itself, and also the visual scenarios related to those music. So this is a creation from this guy. It's not a music from others, although very simple, but it shows the idea of itself. And this is this is playing with with our famous Chinese character teacher from our music school. With my robot, but now it stays as an intelligent tool to coordinate with human. I'm not saying it's a living becoming. We should be very careful about that. But our direction, our dream is to do that. I think I have to summarize and skip some of my slides. So basically, what we need is really not only that we need to find the right way to start the creating process of living AI. Well, on the other side, how should we live with them? Are we really have a big heart that is big enough to say that, oh, okay, AI could be living beings with us. We could have symbiosis. Probably you don't like the story. So this is why in the Blade Runner, the story is totally different. People don't like to live with those AIs, and also people actually does not behave well when they interact with the current robot. And also so this is the film that when I was a year one bachelor student, right, by Steven Spielberg. And what it says, I think it really poked my heart, is really, if a robot could genuinely love a person, what are the responsibilities of a person towards the mega in return? Still fundamental challenge to the human society. That also in Japan, people are creating developmental robotics. And when they were asked whether we could learn, really, tackle the evolutionary process of human development by robot simulation, the scientists in Japan said that, well, it depends on whether we could treat a robot child just like we treat human being. If we couldn't do that, there's no way that we could really understand the nature of development. Maybe you don't really understand the vision for, monks pray for past robots in Japan, but I think you get to know what I mean. That they're perceiving AI as a quasi member. But unluckily, that the Japanese scientists, for now, they're not creating a quasi member. They're still using deep neural networks to create tools. That is the problem. So writing this book, everybody reads it. That is the mirror machine. That right on the Chinese version, the interface, it says, put the machine into the moral cage. That is by my friend, Wendell Wallach and Colin Allen. I was asking Wendell, saying that, okay, now you have in 2015, you're having robots that could cook based on YouTube videos. Now they're trying to watch movies together with humans, although they're pretending to watch movies. But maybe after 30 years, they actually go on YouTube to see how those humans are treating with other, robots or their ancestors. So now who is in the cage? Probably not human. Probably not the robot. Probably human. I'm gonna skip about the details for the harmonious AI principles that I proposed 4 years ago. The spirit underlying that is that we shouldn't only have principles for AI to interact with human. For future living AI becomings, we need principles for human to interact with them. If they are with certain levels of consciousness, or if they have the ability as a living becoming, we should have empathy for them. We should have privacy for them. We shouldn't have bias on machine, and we also should have responsibilities over them. There's a lot that we need to think about in this symbiotic society, which I would like to end my talking here with the topic that me and Roger always talk about, that is symbiosis. That the future society is really a sustainable symbiotic society where humankind is only part of them. We have quasi-members, living AIs. We also have AI tool to support the development of not only humankind, but also animals, plants, and other living AIs. With all that, I thank you for your attention.